Here we're going to be looking at the analysis of sodium triazocarbonate in preparation for the exam that's coming up. And what we have here, we have all our reagents here. We have our sodium triazocarbonate, and we have all the reagents that we need. We have lime water, barium chloride based on the information given. We have barium chloride. We have also an acid there. Have an acid, we have our distilled water. Now, what we are going to do here, we're going to follow a procedure which is already on the board, and I want to encourage you to, watch the next this thing that will be coming up after this very analysis, so that you'll be able to see it stable down on the board for you, so that you understand exactly how to arrange your work. So, in this, the first test here said that to a portion of C is triazocarbonate, that is the tag it will bear during the exam. C is like I said, C is triazocarbonate, sodium triazocarbonate. So to a portion of C, add distilled water and shake. So we get the portion of C. When we get the portion of C, so we get a portion of C. This is our C. We take a portion of it and add into the test tube. Then we put some water. I said add distilled water. And then we shake. And we're shaking it. Shaking. It's like it's soluble. We're coming up. Let's shake very well and add more water to it. Okay, you can see now we have a clear solution. That means it's very soluble. Very soluble. Since it's soluble, what we are that simply means that the the salt in question is soluble. Since it's soluble, we should be expecting an ion like sodium ion, potassium ion, um, ammonium, ion, and then we'll talk about um, hydrogen triazocarbonate 4. Now, all these things I mentioned are known to be soluble in every case. So potassium is always soluble. All the salt of potassium is soluble, and all the sodium salts, they are all soluble, as well as um, hydrogen triazocarbonate. All of them are what? Soluble. That is possible soluble salt you might be expecting um, in this solution we have here. So in the next one, it said that to the mixture above one, add litmus paper. Then we take our litmus paper. These are we have our litmus paper and we test it into, we put inside it to see what we are going to get. Now this is our litmus. We put inside the litmus paper inside it. All right, it's getting there. Okay, that means it turns red litmus paper blue. Turns red litmus paper blue, meaning that the compound here is alkaline. Since it's alkaline, that means um, hydrogen triazocarbonate is likely to be absent. That means potassium, sodium, and ammonium salt is likely to be here. Ammonium ion, they are likely to be here. So the next thing the question here said that we should do, another test we are going to do, say that add the barium chloride solution. We add barium chloride, we have a barium chloride here. We add the barium chloride into it. By adding barium chloride, it gives us white precipitate. Giving us white precipitate simply means that the salt we have here, the compound we have here is likely to be contain triazo carbonate 4. It's likely to contain what? Triazo carbonate 4 or triazo tetraozo sulfate 4 or tetraozo sulfate 6. Triazo triazo sulfate 4, triazo carbonate 4 or tetraozo sulfate 6. These are the ones that can give us white precipitate with what? Barium chloride. Now the next one said that we should add to the mixture from 2 above, add dilute hydrochloric acid. So the next we are going to add is dilute hydrochloric acid. We need to reduce the volume. So what we are doing now is to reduce the volume so that we can say that add dilute hydrochloric acid in excess so that we'll be able to add enough excess to it. So what we have here, we can make do with this one. I think we can make do with this. Let's just reduce a little bit so that our reaction. Now let's carry on with this what we have here. So this is the precipitate we have. We are going to add dilute hydrochloric acid in excess. Dilute hydrochloric acid in excess. Notice an effervescent occurred, and then we have a clear solution. This is a clear solution, and that means the compound is soluble. Since it's soluble, it simply means that what we are likely to have here is triazo carbonate 4. Triazo carbonate 4 is likely to be here, or triazo sulfate 4 salt is likely to be here. So now we're going to the next going over to the next test here. What we have here said that to another solid portion of C, put into a test tube and add dilute hydrochloric acid. So what we're going to do now to another portion of that, we get another solid portion of it, we add into the test tube, we add it into the test tube, we said hydrochloric acid. So what you are likely to do now is now okay, put into the test tube and add dilute hydrochloric acid and then bubble into lime water. So what we do here, okay, what we do now is to get our delivering tube. So get hydrochloric acid. No. and we take the hydrochloric acid, we add into it, then we bubble into lime water, we bubble into lime water, or the gas has already gone, we need to add another more acid. Okay, it's already forming there. Notice the color, as the color coming up. Okay, milky color is coming out a little. Let's add more acid to it and see what will happen. Now notice the milky color that is appearing at the surface. The milky color is coming out. The milky color is coming out. The milky color is turning lime water milky, confirming the presence of what? It's confirming the presence of carbon 4. That means carbon 4 gas is coming out. You can see the thing is turning milky. If you look very well, you find out that it's turning milky now. That means what we have here is carbon 4 confirmed. You can see the color. Look at the down and the up one. You notice that it's turning milky already. That means what the gas we have here is what? Carbon 4 gas confirmed. That is what we have. So the next one we're going to do here is said to the now we have done that, like pumping into lime water. The next thing we say that dip a glass rod or platinum wire. Okay, I'm going to use this now into hydrochloric acid, then into the sample of C. I have hydrochloric acid. Let me just use this. I have hydrochloric acid, and then and heat. So that means we are going to use light now. We're going to use and we have the salts, the sample of our salts. Notice the golden color that is coming out. Golden color confirms the presence of sodium ion. The sodium ion, that's what is forming this golden color, which means sodium ion confirmed. That means sodium ion is present in this. So I want to thank you for coming this far, and like I said, I want you to make sure you watch the next video that will be coming out after this, so that you will see a chart or a table showing all these things that we have done, the same experiments we have done so far. Thank you so much for being part of the class. Thank you.